And that is the universe's greatest lesson. We believed in the rule of visible matter, but we missed an invisible exception that makes up the majority. Do you know that everything we can see in the universe, from the fiery planets, the massive stars, the billions of glittering galaxies, right down to you and me, this breath, this life, actually accounts for less than 5% of the total? That number sounds like a joke, a calculation error, yet it is one of the most shocking truths modern science has ever uncovered. 5% is ordinary matter, the stuff we can touch, see, and measure, the stuff that makes up atoms. So, what about the rest? What makes up 95% of the cosmos? The majority of the universe is dominated by something mysterious, invisible. It doesn't glow, it doesn't emit, and it doesn't absorb any kind of radiation. It's like a colossal, anonymous spirit, present everywhere. Yet, it leaves clear and undeniable traces through gravity. We call it dark matter. But the strangest thing is, to this day, no one has ever seen it directly. Imagine walking into a completely dark room. Your eyes can't see anything, but you sense the presence of objects by how they obstruct and guide your steps. Our universe is much the same. Scientists realize there is something invisible present everywhere because it affects the movement of everything else. It's like a dancer moving behind a curtain. We only see a faint shadow through the movement of the curtain itself. The story begins nearly a century ago in 1933 with the Swiss astronomer Fritz Zwicky, an eccentric genius. Zwicky observed the Coma cluster of galaxies and noticed that the galaxies within the cluster were moving so fast that based only on the visible mass, the cluster should have been torn apart long ago, but it remained stable. Zwicky concluded there must be a huge invisible gravitational force holding them together, and he called it dark matter. The idea was considered radical, and it was largely forgotten for 3 decades. The irreversible turning point came in the 1960s and 1970s, thanks to the work of the great astronomer Vera Rubin. She studied how stars rotate around the center of galaxies. According to classical physics, the farther stars are from the galactic center, the slower they should orbit, much like planets farther from the sun. But when Rubin measured, she discovered a surprisingly flat rotation curve. Stars located at the outer edge of the galaxy rotated almost as fast as those near the center. That shouldn't be possible. The conclusion was undeniable. There must be an invisible, massive halo, 5 to 10 times the visible mass, enveloping the entire galaxy and providing the gravitational pull to keep it intact. Vera Rubin's work transformed dark matter from a wild idea into an absolute physical necessity. Since then, we've seen more evidence. A prime example is gravitational lensing. According to Einstein, mass curves space-time and light must follow that curve. When light from distant galaxies passes through huge galaxy clusters, we see the light bent and distorted far more than predicted based on the visible mass. This degree of bending precisely reveals the immense, invisible total mass of dark matter. Another irrefutable piece of evidence comes from the bullet cluster collision, where ordinary matter, hot gas, was left behind in the center, but the gravitational force was distributed around it, showing that the stuff creating the gravity separated from the normal matter. All the evidence is consistent. Dark matter is real, and it governs the motion and structure of the universe. So what is dark matter? This is the question currently baffling physics. The most favored hypothesis is that it consists of fundamental particles yet to be discovered, lying outside the standard model. The two leading candidates are WIMPs, weakly interacting massive particles, which are very heavy but interact mainly through gravity, and axions, which are extremely light particles. WIMPs have been highly anticipated because they are predicted by supersymmetry theory. However, some still speculate that dark matter could be composed of massive objects made of normal but dark matter, called MACOs, like brown dwarfs. But studies show there aren't enough of them. A more radical alternative is that we have misunderstood gravity at very low accelerations, known as MOND, modified Newtonian dynamics. But MOND struggles to explain large-scale phenomena like galaxy clusters. To find the answer, scientists have launched a global hunt. They've built enormous machines deep underground in mountains, trying to catch a single dark matter particle passing by. Experiments like Xenon-T or Lux Zeppelin use tons of super pure liquid xenon. They believe that, given enough time, a WIMP might collide with a xenon nucleus, creating a tiny flash of light. But so far, every experiment has returned silence. No definitive WIMP signal. This forces them to shift attention to the ultralight particles like axions, with experiments like ADMX, attempting to convert them into microwaves in a strong magnetic field. We even use the Large Hadron Collider, LHC, at CERN to try to create dark matter particles by smashing ordinary matter together and looking for signs of missing energy during the collision. The existence of dark matter isn't just a minor detail. It is the foundation of the entire cosmos. Right after the Big Bang, the immense gravitational pull of dark matter created the invisible scaffolding, the seeds for ordinary matter to clump together. Without it, our universe would only be a faint, dispersed cloud of gas, never strong enough to form stars, planets, and certainly not us. So, let's pause for a moment and think. Something that makes up most of the universe, holds everything together, yet we cannot see, touch, or measure directly. Does this remind you of your own mind? Your consciousness, your emotions, your memories? They shape your life. They guide every action. But if someone asked you to point to where your consciousness is, could you? Like dark matter, the mind is invisible, but governs the entire reality you experience. Perhaps dark matter is the universe's greatest mirror for us. It reminds us that not everything important is seen with the naked eye, that the invisible might just be the foundation upon which all existence rests. Today, giant telescopes like the JWST are constantly observing the sky. Particle accelerators are smashing matter, and supercomputers are simulating the early universe. We are like children groping in a dark room, trying to piece together tiny clues to draw the big picture. We might be on the verge of a great discovery, or we might need centuries more to realize we have to rewrite all the physics we know. And so, when you look up at the night sky and see billions of twinkling stars, remember that what you see is only the thin skin of the universe. Behind that light is the invisible darkness, which is the majority, enveloping everything, patiently waiting for us to recognize it. And perhaps it is in that endless silence that the answers lie, not just about the universe's origin and fate, but about the meaning of us all. The search for dark matter is living proof that the greatest things are still ahead. This is an adventure that you, the viewer, are also an integral part of. Take action today. Sow curiosity. If this story has made you pause and think, Help us spread this light of knowledge. Hit the share button to reach others who love the great mysteries of the universe. Shape the debate. Dark matter is still an open question. We need your insight. Which hypothesis do you lean towards? The mysterious WIMP particles, or rewriting the laws of gravity? Leave your detailed thoughts in the comments section. Let's analyze the possibilities together. Don't miss the next chapter. The big discovery could come at any moment. Subscribe to the channel and turn on notifications immediately, so you'll be among the first to know when humanity finally lifts the curtain of darkness. The adventure isn't over. Keep searching. See you in the vast cosmos.